Hey everyone, in this video we are going to explore one of the most exciting architecture in the world of modern AI, RAG, which stands for Retrieval-Augmented Generation. In this video we will understand what is chunking, embedding, vector database, and how a user query flows through the system and how to retrieve the best chunks. So, what is chunking? Now let's talk about chunking. Imagine you have a long 100 pages of PDF. It is too much for the AI to process all at once. So, we will split the document into smaller parts called chunks. Each chunk should carry a complete thought or idea. It is like dividing a book into meaningful paragraphs. Why do we do this? Because later, when a user asks a question, the AI can search only the relevant chunks instead of the entire document. This makes the process faster and more accurate. Here you can see a PDF having multiple chunks, like chunk 1, chunk 2, chunk 3, and so on. What is embeddings? Now, how does AI understand those chunks? That is where embedding comes in. Embeddings are like numerical fingerprint of text. We use an embedding model to convert text into vectors, numbers that capture the meaning of the sentence. Two similar sentences like India is a country and Bharat is a nation would have vectors that are close to each other. These embeddings help the AI find similar meanings, not just similar words. It is used for smart searching. Now that we have created a vector from text chunks, we need a place to store them, and that is a vector database. A vector database is especially designed to store and search these high dimensional vectors. Popular tools include Pinecone, ChromaDB, and Faiz. We also store metadata with each chunk, like the document title, section heading, or tags, to make the results more informative. This database becomes the AI's knowledge base. Imagine you have a question and you want an intelligent answer. That's where the system kicks in. Let's walk through how AI answer your query using Retrieval Augmented Generation, or you can say it RAG. Step 1, asking a question. So it all begins here with you, the user. You ask a question. Let's say, for example, you ask, how does quantum computing differ from classical computing? This question is captured and sent forward into the system. But here is where the magic begins. Instead of just directly answering your question, we do something smarter. The system takes your query and passes it to an embedding generation model. What does that mean? Well, the question is converted into something machines can understand, a vector. Think of it like translating your sentence into a mathematical fingerprint. The fingerprint captures the meaning and context of your question, not just the words. Step 2, searching the vector database. Once your query is turned into a vector, the AI now searches a vector database. Now, what is that? A vector database is like a big knowledge library, but instead of books, it has embedding of text chunks from documents, articles, reports, etc. So, the system performs something called a similarity search, where it tries to find which chunks in the database are most similar to your question. The more relevant the chunk, the higher it scores in similarity. So now we will see how to retrieve the best chunks. Once the search is done, we get back the top k chunks, meaning the top few passages or pieces of text that best match your query. Think of it like Google giving you the top 5-10 most relevant search results. But here, it is not links, it is actual content chunks. These chunks are rich in information. They contain the real world knowledge that the AI needs to answer your question properly. Now we will see how to pass query to the LLM. Now, here comes the LLM, the large language model, the brain of the operation. We pass our original question along with those best matching chunks to the LLM. And here is the key point. Instead of just relying on what it was trained on, the LLM now has fresh, relevant information retrieved from the external database. Using both your question and the retrieval knowledge, the LLM generates a rich and accurate answer. Finally, the answer is sent back to you, the user, in natural language. Simple, clear, and context aware. No hallucinations, no guessing, just better answer. So, to summarize this, imagine visually. You ask a question, the system encodes it into a vector, it searches a vector database, retrieves best chunks, sends them to the LLM, and finally gives you a complete answer. That is a retrieval augmented generation in action. Thank you.